Now, another type of geometric series would be an infinite geometric series. Just chapter 9, topic 6. An infinite geometric series would be a geometric series where you add infinite number of terms. Okay, there's no stopping point for this. All right, so there's no n because there's no number of terms. Now, the formula for an infinite geometric series is just like the other series formula, except it only has a1 in the numerator. Okay, so the formula is infinite series is equal to a1 over 1 minus r. It's actually very easy to use. a1 is the first term, r is the common ratio. However, this only exists if r is between -1 and 1. Okay, so r has to be a fraction between -1 and 1, or some sort of, it cannot be greater than 1, and it cannot be less than -1. Okay, if r is outside of that value, then the sum does not exist. So find the sum if it exists. So we have our series here, 21 plus 14 plus 28 over 3. Okay, so the first term is 21. Now this is infinite because you'll notice that it doesn't stop anywhere, it just keeps going. The r would be the second term divided by the first term, so 14 divided by 21, which reduces to 2/3, 2 over 3, because this is 7 times 2, and this is 7 times 3, so the 7's cancel, got 2 over 3. Okay, so now we want to say, first we want to say, does the infinite series exist? Well, yeah, it does, because the ratio is between -1 and 1. Okay, 2/3 is between -1 and 1. So we can find the infinite series here by substituting into the formula, a1 over 1 minus r. That'd be 21 over 1 minus 2/3. Okay, so to simplify this, we first start here, 1 minus 2/3. 1 minus 2/3 is 1/3. So we got 21 divided by 1/3, okay, which is the same thing as 21 times 3 over 1, which is 63 over 1, or just 63. So the infinite series for number 1 is 63. Okay, you add all of these terms together infinitely and you get 63. Okay, let's look at number 2. 32 plus 40 plus 50. So the first term is 32. The ratio would be the second term divided by the first term, 40 over 32. Okay, these are both divisible by 4 because this is 4 times 10 and this is 4 times 8. Okay, they're actually both divisible by 8 as well. Okay, 40, that's 8 times 5, and this is 8 times 4. So this reduces to 5 over 4. Now 5 over 4 is larger than 1. Okay, it's like 1.25. Okay, but that's larger than 1, so there's no sum here. So there's no infinite sum for number 2. Because the ratio is larger than 1. You can also tell the numbers are getting bigger. 40, 50, they're getting bigger, which means that there's no sum. If you look over here, the numbers are getting smaller, which means that there is a sum. Okay, that's another way that you can tell. Look at number 3. 1/12 minus 1/6 plus 1/3 minus etc. So a1, first term, which is 1 over 12, r, common ratio, be the second divided by the first. So that's -1 over 6 divided by 1 over 12. Well, let's write this in a way that's easy to read. So -1 over 6 divided by 1 over 12. Okay, well that's -1 over 6 times 12 over 1. That's -12 over 6, which is -2. So the common ratio is -2. Well, that is outside of the boundary, okay? The ratio has to be between -1 and +1. -2 is not between -1 and +1, so there's no sum here either. Okay, number 3 does not have a sum because the ratio is too small. And you can tell because the numbers are getting, besides the negative and positive signs, the numbers are getting bigger. Now, you can also see these in summation notation with the E, okay? This is another way that you can see a series is with the E. You'll know it's infinite because it will have an infinite at the top, okay? Because remember, the top tells you what term to stop at. Well, this one tells you never stop. Just go to infinity. Now, when you're doing these kind, infinite sum, you don't have to plug in the bottom number, okay? This will always be your A1. This will always be your R. So there's nothing to do besides plug these into the formula. Okay, so for number 4, A1 is 8 over 3, R is 5 over 6. First, check to see that there is a sum, okay? Because if your R is not between -1 and +1, there's not a sum. However, for number 4, there is a sum. 5 over 6 is between -1 and +1. So let's just plug this into the formula, A1 over 1 minus R. Simple enough. So 8 over 3 over 1 minus 5/6. Okay, so that's 8 over 3 over, so that's 6 over 6 minus 5 over 6, which is 1 over 6. 8 over 3 divided by 1 over 6, which is the same thing as 8 over 3 times 6 over 1. Now remember, 6 is 3 times 2, so those factors of 3 can cancel. So it's 8 times 2 over 1, so that's 16. So my sum for number 4 is 16. You still could have just multiplied those, 8 times 6, and then divided by 3, and you would have gotten 16. So number 4 is 16. Look at number 5. A1, 1 over 8. R is 1 over 12. First, we ask, does a sum exist, an infinite sum? And yes, it does, because 1 over 12 is between -1 and +1. So we'll plug it into the formula, A1 over 1 minus R. So 1 over 8 over 1 minus 1 over 12. That's 1 over 8 over 11 over 12. Okay, so if we write that as division, it's 1 over 8 divided by 11 over 12. Which is the same thing as 1 over 8 times 12 over 11. Okay. Now these have a factor in common because this is 4 times 2 and this is 4 times 3. So they have a factor of 4 in common. So that would be 3 over 22. 1 times 3 is 3, 2 times 11 is 22. So 3 over 22 would be our sum for number 5, 3 over 22. And number 6, A1 is 4/3. R is 8 over 5. 8 over 5 is larger than 1, okay? So there's no sum here. You cannot have a ratio that's larger than 1 or smaller than -1. 8 over 5 is outside the boundary of your allowed ratio. This will not have a sum. Number 7, write each repeating decimal as a fraction. This one's actually kind of tricky because you have to think about what would this look like as a series. Okay, well, 0.8 repeating is 0.888888, etc. And we can write this as a series because we can write this as 0.8 plus 0.08 plus 0.008, okay, and then just keep moving the decimal over until we've taken care of all the 8s. Okay, well, if we write this as a fraction, because it says write it as a fraction, this would be 8 over 10 plus 8 over 100 plus 8 over 1,000, etc. So we can see here that our first term is 8 over 10. Our common ratio is 1 over 10. Okay, we're multiplying by 1 over 10 because 10, 100, 1,000. We're multiplying the denominator by 10 each time, which is 1 over 10. Okay, so we can use the formula with these two numbers here. So A1 over 1 minus R. So that's 8 over 10, 1 minus 1 over 10. That's 8 over 10 over 9 over 10. Okay, well, if we write that as division, so divide by 9 over 10, it becomes multiplication. So 8 over 10 times 10 over 9. Well, those cancel. Got 8 over 9. 8 over 9 is the fraction representation of 0.8 repeating. If you put 8 over 9 in the calculator, you will get 0.8 repeating. So 0.8 repeating is the same thing as 8 over 9.